Welcome back to BSpice. Under gas detection technologies, we'll focus on electrochemical toxic gas. This is the look and feel which we'll be dealing in detail. Okay, prior to that, see if you are a first time viewer, wanted to inform you in gas detection technologies, we had uploaded few videos. See, like about catalytic bead, metal oxide semiconductor, non-dispersive infrared open path, non-dispersive infrared point type, tunable laser diode absorption spectroscopy, and the last video is about the photoacoustic infrared. So if you are interested, you can watch and get benefited. Let's get on with this electrochemical toxic gas. Yes, as I said, yes, the technology is all about electrochemical, hence that name electrochemical. So it's used to measure, detect toxic gas. What's the principle here? Yes, it uses an electrochemical reaction. That is why the name electrochemical sensor. Okay, it uses an electrochemical reaction to generate a current proportional to the gas concentration. As simple as that. Let's see how it works. The sensor is a chamber containing a gel or electrolyte. The sensor is a chamber containing a gel. As you can see here, this white surface, yeah, a gel or electrolyte, and two active electrodes. One is a working electrode, we call it as anode, and the other one is a counter electrode, we call it as a cathode. So the third electrode, we have a reference electrode. This is used to build up the constant voltage between the anode and the cathode. So when the gas sample enters the casing through the membrane, oxidation occurs at the what? Anode here, right? And reduction takes place at the cathode here. Okay, so reduction takes place at the cathode here. So when the ions flow to the cathode, okay, ions flow to the cathode. I mean, when the positive ion flow to the cathode and negative ions flow to the anode, a current proportional to the gas concentration is generated. That's is proportional to the gas concentration. That's all about this electrochemical toxic sensor principle, friends. Okay, right. In comparison, the MSA vendor, they introduced or developed a Excel sensor that utilizes the identical electrochemical principle but employ a significant physical design, which I will talk in the next slide because it's very tiny. I will talk about in the next slide. Okay, coming back to this subject. Yes, the readings are in ppm. When we talk about the pros, yes, very high sensitivity, very good. Linear output, excellent, easy to handle. That's all the pros, yes, but the cons is bit of, worry. See, limited shell life. You can't, keep this for a long time. So we need to verify when we order, okay, what is the shelf life? And it's subject to interference, sensor lifetime shorten in very dry and very hot environment. So the performance also impacted by extremely humidity environment. So we need to take care of all these friends. That's all about the electrochemical toxic gas. Okay, now let's see the Excel, the electrochemical toxic sensor. Yeah, there is no much, there is similarity in terms of the electrode, in terms of the reference electrode, counter electrode, electrolyte, but the shape and look and feel is different. And additionally, we have a circuit board with ASIC, right? So this mechanical design of the Excel sensor is optimized for the most effective interaction between the electrolyte and the electrode catalyst and the target gas, regardless of the environmental conditions, okay, to overcome. So basically this is targeted for effective interaction between the electrolyte, electrode catalyst and target gas, regardless of the environmental conditions to overcome. So that's all I have for this technology, friends. Okay. See you in the next topic, which is also about electrochemical sensor, but that is for oxygen measurement. Stay tuned. Thank you. Take care. Bye bye.